This is an overview of the MultiTurn XS series, which is fitted with the Fanuc series Oi TF Plus control. Also built into it is the alpha side of the control, which is exclusive to the XS machines, written by Harrison over in England and Fanuc. So when I switch over, I may get this message. That's because the pot was on when I switched over. To get rid of it, turn the pot off, start the spindle, and the message will go away. To move things around, I can change my selection speeds here or up in here just by pushing the screen. So at that point, I can move things out around a little more rapidly compared to, starting to slow it down. And of course, the smallest is going to be basically a tenth per click on the graduation of the hand wheels. Okay, to start the spindle, again, we put the lever down. If I raise the lever up, it's going to swing the chuck in the opposite direction. Then I can turn up the potentiometer to whatever RPM I want to run it at. Besides just moving things around manually to take a minor cut, we can also go into the hand and we can gauge a feed lever. I can change the feed that I want to cut, and that's by pushing the button and going up to like 16 thousandths per rev, and then gauge my feed lever. So now I'm moving, select the direction that you want to cut it, and then engage your feed lever. And she is moving now. To disengage, just hit the lever again. So what we're going to do is we're going to activate tool number 1, because we're going to use that, and that's by pressing the hand button there. But we're going to use tool number 1 to set the work shift. So go to 1 and input, and it updates the tool 1. So now I'm going to go ahead and start the spindle. And we're going to come over and turn that up a little bit. And of course, if you have a saw cut part, there's going to be more material than what I'm doing to clean it up. And you don't necessarily have to face it completely off. What you're trying to do is establish a surface that we can calibrate by for the other tools. And also to set the work shift based off of it. So speed that thing up. And once I come back out in X axis, I'm going to hit the Z icon and type in 0 and hit the datum button, because the tool number 1 is my datum tool as the master tool. And now, once we have the Z set, we're going to actually turn the OD and mic it to set the tool offset for the X-axis for tool number 1. And this is what they call the cut and measure. So I'm going to restart spindle, go in on X, and then I'm going to take a easy cut with Z. All the thing we're doing is actually truing up the surface. I'll back Z off. And then shut off the spindle, and we're going to go in here and mic it. So what we got is we mic'd it at 4.587. So I'm going to press the letter X and type in 4.587. 587, and then press input, and you'll see that the size now shows that. The other thing we need to do for tool number 1 is we're going to go back in the tool and actually set the tool vector code, which is number 3, and also the tool nose radius, so 0.031 input. Another nice feature that the Alpha can supply you with is CSS capability, even on the Alpha side or on the manual side. So to set it up, what we have to do is actually go into the S command, which is your spindle speeds. Turn on the spindle, and the first thing we want to do is set the max RPM that you want this thing running at. So I'm turning the pot up to where I want this thing to cap off, and then I hit this key here, and what you'll see that being stored in there, and it's also stored there for max spindle speed. Now to set the CSS, the feet per minute, you can turn your pot back down and then hit the button. If you want to fine tune a little bit more, then you can also change your X display or X axis and get down to an exact number if you wanted. Once you're there, hit that key, and then it's stored up there. So at this point, I'm going to go ahead and back out of the screen. I'm going to turn the spindle off. I'm going to activate CSS. Turn the spindle back on. And now I'm going to move the X-axis. So the RPMs are increasing with the surface feet per minute. And I'll max out what I set it at, the 981. If the CSS is active, and you can hear the changing of the RPM, to deactivate it, shut the spindle off, and then turn the pot off. And then I can disengage the CSS. Also, a really nice feature on the Alpha side of the control, and this is more for the manual machine operator to make them a little bit more comfortable and familiar with running this compared to also a manual lathe. But if we develop what I'm going to call is electronic stops, it's a boundary, a safety boundary that the machine won't go past once it's engaged. So if I create a new cycle or dimensioning for the stops itself, I'm going to go with an OD setup, and I'm going to say X that it wants the minor diameter. So let's say it's 5 inches, and my Z endpoint, then I'm going to machine to, let's say Z minus 0.5. Is there a radius back there? If there is, then you fill in that. What is my feed rate that I want to run this thing at? Let's go 012 and input. Now, what I'm going to do is I'm going to save this as is. So hit the check mark, and we have that information on the top of it. So when I activate the cycle itself, I don't even have to have the spindle running at this point. So I'm going to cut in the Z minus direction. But once it's active, now my electronic stops are in place. So when I move this thing down, it will stop at that value. And I can come back out, and I can go down to the X minor diameter, and it's basically stopping at the 4.9999. So that will stop them from running into the part, as long as they put in the correct numbers. So if I have the spindle running, then I can go, and I still have the CSS active at this point. I'm going to engage the feed lever, and it's going to feed to that Z minus ½ inch, and it's going to pull off both X and Z off the part, so they get the tool tip off the part. Then I can go back out to the next depth of cut, hand wheel in, and engage the feed lever again to take another cut. Once it's done, we then can pull back off the part and then disengage the stops condition and shut off the spindle. Another item that for the spindle side of things is that we do have a gear change capability to get 3 gear changes speeds and to allow more torque at any given speed. So to change it, we don't have to have the spindle on or anything, but I do need the pot off of 0. And then I just press the low, medium, or high, whatever gear I want to shift it to. And then it will automatically do it. Now, once it's completed, then it says that, you know, turn the pot off and restart the spindle. So I went to high, and now I'm going to go to medium. It's shifting again, turn the pot off, and then start, and as you can see, the RPMs are much different. So since I've got tool 1 set, I can go ahead and go on to another tool. So what I'll do, first of all, is I'm going to switch my tool around to tool number 2. And I'll call up tool number 2. Okay, then now what I'll do is I'll get the hand wheel mode going and come up, and in this case I'll just touch off Z first. Now I will be using the paper thickness, you know, to go by, so I can feel when I get up to the Z0 point. So we'll get up close, and then we're going to slow it down. So right now I'm pinching the paper, and what I'm going to do is I'm going to tell it that we're at, based off the paper thickness, 0.002 off the face of the part. So it calibrates that I'm at 2 thousandths away from the face. Now I'm going to move X out and Z down to touch the OD of the part. So when I'm at 1 thousandths per click on the graduated manual pulse generator, I'm not putting a whole lot of force on it, so I'm pretty accurate on how I'm touching this thing off. So at this point, I would hit the letter X to calibrate the value that I had when I mic'd it earlier, and that was 4.587, but what I'm going to do is add on 4 thousandths for like paper thickness doubled. So I'm going to go 4.591 and then input. And then the next thing is, again, tool vector and the tool tip radius. Now in this case, the tool tip radius on this one is 16 thousandths. It's a smaller radius tool. Another example of tool calibration, I'm going to do a threading tool at this time. So I'm going to get Z back out of the way a little bit so I can index around the threading tool. And I will do X first in this time because I want to explain a little bit about the Z axis. So I'm going to hand wheel in until I again pinch the paper. And get Z back out of the way. And then call up, even though I didn't do it before, I still haven't calibrated, so I can do it now. And I'm going to call it the next tool for the threading. And then for X, I'm going to type in that same value with the paper also included. So it was 4.591, and then input for that tool. Now, Z, for the threading tool, to me, the best thing to do is touch the left side of the tool. I don't care where that point is at, because it's the side of the tool that's going to hit a wall first. So that's what we're going to calibrate by. So I'm going to bring it up till the paper is pinched, and then I will do Z 0.002 in the sense, whoops, 0.002 input. And then I will back off. Now for the threading tool, the tool vector isn't necessary, nor a tool nose radius, because it's not doing a compensation for a tool nose radius. So one of the other things, because we had already covered about electronic stops, well, now I'm going to create an actual cycle, a turning cycle, or what we call a box cycle. So I'm going to go back into the cycles. Now we could add on to what we already created for the stops, but I'm going to change some of the values in there, or I can just start with fresh. So if I started fresh, I go with an outside turning. X, I'm going to go down to 4.5, and Z, yeah, let's do minus 0.5 on that also. And then no radius in the back of the turning, and then feed rate of 0.012. Now, if I hit the check mark, that goes back to that electronic stops, okay? But I'm going to continue on by going into either a finish pass or a roughing cycle. So I'm going to go into X, and we're going to start at, let's say 4.7 is my starting diameter, and Z start is going to be at 0, and my depth of cut per side is going to be, let's say 50 thousandths. And do I want a material for a finish pass? I would put, for X-axis, I would put that in here, and Z-axis I would put in with a W. I'm going to leave that alone, and I'm going to hit the check mark to accept this. So now we have the upper part and the lower part, and this is where it's going to start from to get down to that value. Okay, so what we're going to do is start the spindle, get the spindle running, and then select the direction of cut. Now this comes up because I'm still quite a long ways from starting of the cycle, so it wants me to hand wheel in to where the control is satisfied in both directions. So Z stopped, now I move X in to a good starting point, and so now it's happy with that. So I'm going to go ahead and engage the feed lever. So this is where it's going to take a cut. So basically the cycle is done at this point. So to disengage, press the Z again, and you can turn off the spindle. As we previously seen, that we could make these operations very simply, but we can also save up to 25 by using the arrow up and arrow down. So if we, like if I arrow down, we see operation 25. If I arrow upward, then you're going to see, you know, different items that I could save. So it's not like you're limited to one. We can actually stack these operations. So we could do a roughing and then a finish and then grooving and threading, and just call up the operations and run it. So one other item that we're going to cover on the alpha side is the thread cycle. So I just have to press the icon for the threading. We also have taper turning and grooving. We're going to basically bypass those and go to the thread. Once you understand one of these cycles, the rest of them are going to fit right in, because they're got a lot of the same questions that you're filling in on those. So I'm going to first activate the tool that I want to use for the thread cycle. Well, my threading tool is tool number 4. And then the X1, that is your outside diameter. And in this case, it's 4.5. That would have made a mess. And then my X2 is your minor diameter of the thread. We're going to modify this just for demonstration purposes, so it doesn't take too many passes. But I'm gonna put that at let's say 4.450. So it's only 50 thousandths total depth. And then my L is, where is it from the end point of Z that the thread is going to start? Well, if we're going from Z0 in 1 inch, then the Z is going to be a plus factor and the L is going to be just below that. So, or they can be the same. So the L, I'm going to put it, let's say 0.9, and it's a whole value, not a negative number. And for my Z, I'll put Z distance at a -0.9. So that way because I'm turned back 1 inch, I don't want to run into it. And then my P, now we have a choice of what kind of thread we're going to do. I'm going to select threads per inch, and I'm going to put in there 12. So I'm going to run 12 threads per inch. The A is for the included angle of the thread itself. So we'll put in there 60. And then the N here is number of starts. Well, we only have a 1 start thread here. You can do 2 start, 4 start, whatever your part is needing. The NP here is how many passes it's going to take to rough this thing out. And then, so if I have in there 10.1, it's 10 roughing passes and then 1 spring pass. Okay, so I'm going to put it at let's say 5. Oops, press that, and then let's say 5.2. So I'm going to rough it out in 5 passes and 2 spring passes. And I also have the selection of a 90-degree pull out compared to a chamfering out length. So I'm going to hit the check mark to accept it. Now I can start the spindle. Set your spindle speed to what you want this thing to run at. Now once I engage the feed direction, the spindle locks in. So this pot no longer does any good. That way it can be adjusted when it's tracking the thread. But it's still asking me to wind into position to a safety point. Once it's satisfied, it goes back to the screen, and then I can engage the feed lever. It should be 2 more passes at that diameter here. Those are my spring cuts. Okay, this thread's done. Now, like I said, I wasn't going to the full depth, only because we were just doing it for the video purposes. This is another feature for the alpha side of the control for the XS lathe. It is what we're going to call is the thread repair. So to get into it, well, first of all, we want to go to low gear because we are going to track the thread and adjust movements according, while it's tracking it. So I'm going to go into the cycles, go into thread, and going to go into OD threading, and then we're going to select this. This is for the thread repair itself. And then whatever direction we're going to cut. In this case, it's going to be toward the chuck. And then what tool we're going to use. My X is my major diameter. And again, the L is this start of the thread from the end position. So I'm going to put that at 0.9, and I'm going to have Z end position at -0.9. And the P for threads per inch, and we're going to say that the part that we reloaded into the chuck, it has 12 threads per inch. Now, obviously, you have to go through the process of indicating in the part for run out and everything, but for it to pick up a thread after it's been taken out of the chuck, we will use the hand wheels to adjust for the tracking. So once we get this set, we hit the accept button, and we're going to start the spindle. And obviously, the slower the spindle, the easier it is to track it. So once I hit the Z minus, it's going to turn on the thread repair, and it's wanting me to hand wheel into a safe start position. Okay, so when I engage the feed lever, it's going to come up with a prompt, so we have to follow those. I engage the feed lever, it says hold the rapid key. It goes to the start of the first pass, and then engage the feed lever again to take a pass. Now, as this is taking a pass, we need to be looking at the tip of the tool to see how it lines up with the thread itself. Now, granted, if I had a longer thread, it would be a lot more time to adjust myself on the tool tip. I'm going to hit the hold the rapid key, go back to the front, engage my feed lever again to get this pass started again. Now, what we're going to do is I'm going to move the Z axis, the hand wheel. It is making an adjustment on the tracking by 17 thousandths. So as it was tracking, the tool tip is either going to increase or decrease on the tracking. And what we're doing is we're going to continue to do that until we find by eye that the tool tip is getting lined up with the actual thread track. So let's go hold the rapid back out to the front, engage the feed lever, hold that again, engage the feed lever. And also I can move X into while I'm doing this, because I got to work my tooltip down toward the bottom of the thread. Now remember, it's all by eye. And so I make another change in Z. It's going to make that change and keep tracking from there. And go back out of the front. But that's an overview of the thread repair. Now granted, it's easier to work with this when you got your hands on it, watching it do this.